today I'm just going to go over some of the properties that we've already looked at in class that have to do with the stickiness of water. So the first thing we're going to talk about is melting and freezing. So these are concepts you should be familiar with. Melting is going from a solid to a liquid. It's a phase change. And freezing is the opposite. It's going from a liquid to a solid. And both of these happen at 0 degrees Celsius if we're looking at water. And so the question is, at 0 degrees Celsius, is water a solid or a liquid? And hopefully you remember from the phase change lab that we did earlier this year that when we're at 0 degrees Celsius, we basically have ice water. So we have a combination of water in the solid form and the liquid form. And both of those states are at 0 degrees, we're getting an interchange between the two. So solid is going to liquid and liquid is going to solid and back and forth as long as we are at 0 degrees Celsius. If we continue to add heat, more of the solid is going to continue to break up into liquid and eventually it will all melt. All right. Solutes, adding something like salt or sugar or something that dissolves in the water, will affect our melting and freezing. So why is it that if we add a solute, the melting point goes down? And this has to do with the interactions between the molecules. So if something is in the solid form, like we have here, the molecules are interacting with each other. Okay, we have that strong hydrogen bonding network that holds the water molecules together. If, however, we dissolve something like salt in the water, then we have ions that are here also interacting with the water molecules, and that is causing the water molecules to not interact with each other as well or as often because they're distracted by the salt ions. So when we add a solute, it causes the water molecules to not be as organized, and we need them to get organized in this lattice like this if we're going to have them in the solid form. So when we add a solute, it causes the melting point to go down because we need to make it even colder to get them organized in that way. Now let's take a look at the stickiness of water. Cohesive forces are those forces that hold water molecules together. So if we are looking at a sample in a test tube, in here in the middle region is where we have our cohesive forces. They're shown in blue here. And on the edges, the way the water interacts with the sides of the container, the test tube or the capillary tube, that is called adhesion. So those forces are forces between water molecules or any molecules and the container that they're in or another substance. Okay, so this contributes to surface tension. So in the case of surface tension, the molecules interacting with each other on the surface of the water is really strong, and so if you put just a small amount of pressure, such as a mosquito landing on the surface of the water or the paper clip that we did in class, then you can see that things that are not too heavy can sit on the surface of the water because of that additional surface tension. So surface tension is going to be strongest when the cohesive forces between the molecules are strong. So this is why if we add soap to the water, we interfere with those cohesive interactions because the soap has both polar and nonpolar elements, and we disrupt that cohesion. And so the surface tension of soapy water is much, much less than it is for just plain water. Okay, the other thing we looked at in class was a meniscus. And so I've talked about the meniscus before because it's important for getting an accurate measurement of volume using a graduated cylinder. So we always, just as a review, always measure from the bottom of the meniscus when we're trying to tell what volume we have. So if there were lines here on the side, then we would be looking at this line here to know what the volume is. The reason that we have a meniscus, this curvature in the surface of the water, is because there's some adhesion to the side of the container, which is shown here in red, those arrows there. And then there's also cohesion between the molecules in our sample. And so if there was only adhesion, then we would have just a little bit coming up the sides, but the cohesion means that these molecules follow. So those are attracted to the side and these molecules come up as well. And so if we have a small tube, like a capillary tube, then these molecules are going to keep moving up and these are going to keep following because of the cohesive property. So capillary action is a combination of adhesion and cohesion working together to suck up that liquid up into the small tube.